All right, welcome to the High Density Electronics Center, the clean room. We have a 4,000 square feet clean room, class 1,000 in some areas, class 100 in others. Basically, we are going to be transitioning from being a thin film facility to a silicon carbide IC fabrication. I'm going to just be talking basically of the different bays and what we propose to put in each with the new facility. Behind me is actually our staging facility where new equipment or supplies would come in from outside and be prepared before going inside the clean room. This dark area here, apologize for the lights not working, will be for two different items. We'll have the high temperature anneal as well as chemical vapor deposition for the silicon carbide devices. So a lot of the heavy equipment that's a high temperature and the nasty gases will be in this large area that you see here. As we move down from basically the class 1000 area, we're moving further down the clean room bay in order to look at what you'd see in the class 100 area, which would be our lithography. So we would have our steppers, coaters, and develop benches in order to transfer patterns with a resolution down to half a micron as an example. We would also have metrology tools to inspect our materials, ovens, and even ashers to clean parts if needed. Then as you go further down, we'll go to our metal etch bay where we will do either wet or dry etching of components, so acid etches, RIEs, deep RIEs, etc. will be located in this particular bay, which would be class 1000. And then the last bay that we have would have our basically most of our PVD, physical vapor deposition, to do the various different metallizations that are needed in order to build these devices. All right, now we are in a different lab. This is what our low temperature co-fired ceramic lab is located. It's part of the whole of vertical integration, because after we've made the high temperature silicon carbide devices, they need to be assembled, put into a substrate and tested. And so this is a facility, our low temperature co-fired ceramic, that is capable of creating high temperature substrates that operate from say 300 degrees, 350 degrees, all the way up to 500 to 600 if you go to high temperature co-fired ceramics, in order to place the bare die on a substrate that can be tested at high temperatures. And you're just looking at a suite of the equipment that's needed in order to make the ceramic substrates that the devices would be placed on. All right, so now we're in our assembly lab. So regardless of what substrate we decide to use in order to put the active die on, we're going to want to attach everything together. So there'll be the active die, there'll be the substrate, and there'll be passives. So in this facility, what you're seeing is the equipment that's needed to either do dicing, wire bonding, flip chip or die bonding, solder reflow as an example, in order to connect our various devices, passives, and active components on a substrate so that we can move from assembly to testing.